Good afternoon. It's my pleasure to be here again after I left this university in 1989. And I think that this is only one small part of my project, and it's not come out entirely yet. But I would like to share the experiences of my study here with you. And my main purpose is to have more comments and questions from you so that I can modify my writing in such an extent that it can be published. My title is Acoustic Properties of Taiwanese Nasality. So for the background and motivation, I have to introduce you to the language, Taiwanese, and then some backgrounds of nasality in the literature. And then my research questions in this part. Make a better view. There we go. Okay. Taiwan is a very small island, but it's a kind of a treasure of linguistics because there are a lot of different languages spoken there. Basically, there are two language families. One is Austronesian language, and then the other is the Chinese language. The main focus is the Chinese language. There are three dialects of main languages because each of them is entirely unintelligible to each other. Southern Min is so-called Taiwanese, and the Mandarin is the lingua franca in Taiwan. The Hakka is a minority language. The Southern Min spoken in Taiwan is called Taiwanese because the population accounts for about 75 to 76% of the whole population. And Mandarin is the formal language and the national language, and the Hakka is a minority, and I'm a speaker of the Hakka. So my main study is focused on Hakka studies, but you see, as a part of Taiwanese, I am asked or required to do some research on this language. And this is the basic distribution of the language. You can see that the white part is the Southern Min, and the green part is the Austronesian languages, and the others are Hakka. And the focus I'm going to do today is nasalized. Nasalized vowel in Taiwanese is a phonemic. So we have contrast between E and E, and with the same tone and the same syllable. O and O, R and R. And the distribution of nasality in Taiwanese is the first one is a vowel can occur as an independent syllable like E. That's the first. The second part is it occurs after any consonant except a voice that stopped, like a BDG. So we have me, we have B, we have C, and other lot of nasalized syllables, but we don't have B. The third one, it does not occur before a coda, so it's only appearing in the so-called open syllables. We have nye, we don't have any syllable closed with a coda. The fourth one is voice that stops and nasal consonants are in complementary distribution in onset. So MNG and BDG are usually treated as allophones in this language. As proposed in Chung 1996, the syllable structure for Taiwanese is specific in that coda constitutes a unit, while CV or CVG or CGVG are of CV in phonology. This means that if in terms of a phonological account, CV or CVG are treated as the same syllable structure, which is constituted of C and V, while the coda is another independent domain for the nasality. Okay. So in the syllable structure like this, we have CV and the CVG and the CGVG all have a nasality in this domain, or the segments within this domain. While CVC, in this case, only the coda can be allowed to have a nasal consonant, while the others are prohibited from nasality. Now, in terms of phonetics, there are a lot of questions. The first one is that nasality for the nasal or the nasal vowel is stronger than the derived, so-called that nasal consonant plus nasalized vowel. Okay, something like that. There are a lot of questions which are waiting for further studies in phonetics. However, there is very little literature in the history. So most of the literature on nasality now, we can see most on that sound synthesis, mechanical modeling or coupling, based on artificial language instead of natural languages, like in the literature Hawkins, etc. In terms of Taiwanese nasality, the focus was on which part is more salient in nasality, as a study in Pan and Chang. As argued in Kawasaki 2011, the peak of a nasalized vowel conveys more nasality. That's the whole literature we can get. So my question, usually the so-called general properties of nasality in phonetics, these are generally seen in the literature. The first one, where there's a reduction in the intensity of F1, whether there's an anti-resonance revealed in the elimination of F2 or F3, whether there's a presence of reinforced harmonics, and what can be indicated in the shift of formant positions, because sometimes the appearance of nasality will reduce the first formant or the second formant. The methodology, I found 24 subjects or participants, female and male, each 12, all from southern Taiwan. Well, Taiwanese are normally spoken in the family. And I used the word list to elicit all the sounds possible for the nasality syllables. Okay, so in total, I have 576 items under study. And I use plot, which comes out not so very well in my study. And it just testifies that it's a very good instrument waiting for the study, for the modification. Okay. And this is nasalized A and A and Ne in Taiwanese. And then we can see this is called nasal Q or nasal anti-resonance here. This is for A and this is for A. There's a minimal pair like AR and AR. And this is for Ne, nasal and Ne. There are some difference between that phonемicalized A and the derived A. There's somewhat difference. There's a comparison between the French A and the Taiwanese A and A here. There's a theory, so-called pole and zero, but the time limitation will when we from further study. And the result is that the vowel format is shown here. Okay, that's the difference. And this is the plotting. We can see I will just mention this. Okay, there's somewhat difference between E and E in terms of the format distribution, and A and A. But in this case, there's no great difference for F2, but there's a difference for F1. Okay, well, this one is somewhat different. And also, gender plays a very strong role in the distinction between A and E and E. Okay, so the conclusion is that, yes, all that acoustic properties revealed in the literature can be seen in my study. That's the first major finding. The second is that everything is not so clear because variables are too many. The gender plays somewhat difference, and the sound itself is different. I mean, the recording process. And the third one, the instrument, the plot itself manifests more problems than solutions, because if we use different frame of windows, the results are different. Okay, so in that case, I cannot make a final concluding remarks on what I found in the acoustic properties in Taiwanese. That's all my presentation. Thank you for your attention.
And I'm going to open up the question session.
Can you explain further what are the differences that you have seen in plot when you use different frames?
Yeah, if we use the frame, say if I just cut the same frame within, say, 1 millisecond or 3 milliseconds, the formants and the anti-formants or resonance are different. Even the intensity will show so various, not so consistent. Yeah, for the same vowel and for the same target, with different frames and the different window shaping.
Is this the spectrogram, formant tracking, or spectrum?
Formant tracking, yeah.
Formant tracking.
Yeah, formant tracking. So I used more, like, say, I used this. This is a kind of normalization of the vowel, adapting the Z-score. Okay, I try to calculate each formant with 11 points, which means that's 10 distance. Okay, then we'll show that the E, R, and R, there's not. You can see the formant. There's a formant 3 here for oral vowel, and there's a formant 3 for nasalized vowel. This is lowered because the appearance of added nasal formant here. Yeah. So I realized that computing a plot, the rationale, it says that when the first point appearing here is taken to be formant 1, when there's another point or so-called frequency peak captured here is taken to be the second formant, although it's not at all, it's a nasal formant. Okay, but it will be taken into the second formant. So that's the original second formant will be counted as the third formant. Okay, so this is why there's variation for the nasalized vowel. Yeah.
I was saying that this is really not
Yeah,
Pat's fault or not
yeah.
Paul Boersma's fault, because Foreman measurement for already is difficult. Foreman measurement for U, for example, F1 and F2 are merged together. That just make it super difficult. So you lose count of where you have the distinct Foreman peak. Nasalization is, of course, by definition, difficult. So I would think the formant display in prod shouldn't be sensitive to frame variations, but formant tracking could. And spectrum display will be different if you take different size of frame, because they're displaying the average.
Right.
So if that is formant tracking, yeah, Prague can do it, but there's nobody else who can do it. So what can we do? I mean, just probably measure the spectrums.
Yeah. And then, so what occurs to me is that I might count each so-called frequency peak of the nasal cue or nasal properties, and then sort it out to see to what extent it will influence the production of the vowel. And we can make a comparison for that so-called natural language nasality, and the nasality coming out from the coupling or pole zero theories. That's the next step that I'm trying to do.
So you mentioned gender has a lot to do with your data. So could you say a little more about that?
Yeah. We can just see that E here, okay? And for the female, the E and the E here, okay? You will see the great difference between the F2 here, okay? Much more than male. And I think it is a significant difference for the gender itself. Yeah. Mm-hmm. Tongue position, yeah, yeah. But as it is indicated here, yeah, this is somewhat the role for the distinction between male and female in the production of oral and the nasalized vowel. Yeah, but I think that's from the social linguistic perspective, gender always plays a very significant role in the sound distinction, right? So it's not surprising to me. What I'm trying to categorize, or try to put it into a generalization, is how far is the difference will be revealed in terms of gender difference. But thus far, I think that the data thus far is not big enough for me to make such a claim. But I will do that continually. Yeah. No more question? Thank you.